Hey guys, welcome to another episode of MrLopezClasses.com. In this episode, we are going to analyze the different procedures to do the recovery of the refrigerant in different type of marine equipments. And we are going to analyze the procedure to do the vacuum in the system. And finally, the procedure to recover, to add the refrigerant into the equipment. Yes, it's a wonderful episode. And before we start with the system, we are going to review the tools that normally we need in this business in order to do service, in order to do troubleshoot, and in order to do diagnosis in marine air condition system. Those are the different type of tools. I am going to explain the tools necessary to work in marine air condition equipment. There are two elements that are fundamentals. One of them is the set of gauge. The set of gauge is very, very important because with the gauge we know the pressure in the system. Remember, in previous episode I explained that the refrigeration cycle is based on the pressure of the refrigerant. The pressure in the low pressure side of the system and the pressure in the high pressure side. High pressure side and low pressure side. With this gauge, with this set of gauge, you can read the high pressure and the low pressure of the refrigerant. And this is the typical set for marine application, and those are the type of fittings. Those type of fittings. Be careful because there are sets like this, similar, but with the fittings for automotive applications. The set is the same, but the hoses, the fittings are different. Yes, you can buy adapters to convert one set into the other one, to convert residential and marine pressure gauge into automotive. And you can use the adapters that you have on the screen right now. Okay, the set of gauge is one of the most important equipment. Other important equipment is the multimeter. You need a great multimeter. Once again, I love this brand, but you can use the brand that you prefer. We are going to check a lot of capacitors. We are going to verify start capacitors, run capacitors, and of course, we are going to follow my video clip about the procedure to read capacitors and the procedure to verify if the capacitors are in good condition. We need a good multimeter. Digital, if it's possible, is better. Digital multimeter, very important. Okay, we need also temperature laser gun. It's an important tool because we are going to check the temperature of the pipes at the output of the compressor, the temperature at the input of the compressor, the temperature at the entrance of the evaporator, in the output of the evaporator. We are going to verify all the time temperature with this equipment, the temperature gauge. And also we are going to use this equipment. This is the leak detector. The leak detector is critical because in some cases you have a leak of a refrigerant and you don't know where is the leak. With the leak detector, it's easy to identify. In order to use the leak detector, probably we are going to use this developer dye. We are going to introduce a little amount of this colorant in the system, and after that, with the detector, it's easy to identify where it is. We need both of them, the developer and the leak detector. Those tools are important. We are going to use the vacuum pump. The vacuum pump is important when you recover the refrigerant. We are going to use the vacuum pump to remove moisture. The function of the vacuum pump is remove moisture. ABYC question. And yes, I am going to explain the procedure to use the vacuum pump and how it's necessary service the vacuum pump. You need to replace the oil on that compressor, vacuum compressor,
and verify the level of the oil. This is very simple, the vacuum pump. In some cases, if you want to be dedicated to work with the marine air conditioning equipment, I recommend try to buy this equipment. This is the recovery equipment, the recovery machine. With this machine, you can recover the refrigerant and you can charge again the refrigerant. Of course, if you want to work in this business, you need the recovery tank. Probably you need more than one, because depending of the refrigerant used, you use one or other one in order to keep the refrigerant storage properly. Okay, recovery tanks, and also you need a lot of refrigerant tanks with different refrigerants according with the refrigerant of each equipment. And other equipment that we are going to use are the flare kit. In order to do flares on the pipes like this. This is an important tool. You have the tool to cut the pipes, and you have the tool to do the flare. Flare kit is critical, is necessary, is mandatory if you want to work in this business.
Recover the refrigerant is critical. Recover the refrigerant is catastrophic if you drain the refrigerant into the environment. It's important recover the refrigerant in the appropriate tank. It's important recover the refrigerant in the properly way in order to avoid damage on the compressor of the equipment and also damage into the recovery machine. For that reason, the selection of the tank to recover the refrigerant is important. There are specific tanks according with the refrigerant, and also the recovery machine is a vital component in this process, especially in the recovery procedure. Yes, we are going to use a recovery machine in order to explain the procedure, the different type of procedures to recover the refrigerant, and also we are going to do the procedure to do the vacuum on the system. We are going to analyze how is the procedure to connect the vacuum pump and the procedure to connect the vacuum gauge in order to verify if the procedure is going down. And step by step we are going to do those process, and we are going to do the process in two different type of equipment. We are going to do the process in a self-contained unit, and also we are going to do the process in a trainer stand that we have prepared for our students in the laboratory. In that trainer stand, we are going to recover the refrigerant, we are going to do the vacuum, and after that we are going to add it again refrigerant in the system. I hope you enjoyed this video clip, and we are going to follow those procedures step by step, one per one. We are going to start with the self-contained unit, and in the self-contained unit we are going to analyze the different type of methods used to recover the refrigerant and the equipment that we need in that process.
Now we are going to explain the process to recover the refrigerant in an air-conditioned unit, a split unit or a self-contained unit or chiller unit. The process is exactly the same. Equipment that we need in this process. We need safety goggles, of course. We need gloves. We need a set of gauge like this, low pressure, high pressure, that's the manifold and the hoses, and we need an extra hose. Normally the people prefer a yellow hose, any color, but the yellow is better for learning purposes. Okay, we have the set of gauge, the goggles, we have the gloves, and we are ready to start. And also we need this unit, the recovery unit. This is a special unit designed to recover the refrigerant in air conditioning equipment. Internally, this unit have a big condenser, large condenser, have a fan, and a compressor. It's like an air conditioning equipment integrated. Condenser, fan, and compressor. And additional have a compressor protection regulator. That's an important element. And also this element have a high pressure cutoff switch. High pressure cutoff switch to protect the equipment in case that the pressure pass the limit. Okay, and we need the tank, and a special tank to recover the refrigerant. Remember that there are tanks according with the refrigerant. For example, if the refrigerant is 410A, you need a tank that with the label 400. Remember that the tank should be filled no more than 80%. ABYC question. And this is another EPA question in the EPA certification that we are going to take. Yes, never charge the cylinder, the recovery cylinder, more than 80%. This is a critical point. And select the cylinder appropriate for the refrigerant. For that reason, I recommend in your car, in your minivan, try to keep different recovery tanks depending on the refrigerant commonly used in your boats. Okay, an additional you need a scale, because the idea is try to recover the same amount of refrigerant and try to put it back the same amount. In order to avoid mistakes, it's good idea verify how much is the weight of the cylinder. You need to turn the cylinder and verify how much is the weight of the cylinder empty, and verify how much is the refrigerant that you can recover. Normally the cylinder, they have in the label the weight with the cylinder empty 18 pounds, and with the refrigerant is 26. In other words, with this cylinder you can recover 8 pounds of refrigerant. Okay, we have the cylinder, we have the scale, we have the recovery machine, we have the set of gauge, the additional hose. Now we are going to talk the different type of recovery methods. Basically, there are 3 type of methods: the liquid method, the vapor method, and the push-pull method. The liquid method is a method that recover the refrigerant in liquid state and transport the refrigerant in liquid state into the cylinder. Is the fastest method used to recover refrigerant. It's not the most common, it's the fastest. It's good when you need transfer refrigerant from a cylinder to cylinder. This is excellent. And of course, it's the fastest method. Now we are going to start to explain liquid and vapor. The next method is the vapor method. The vapor method is a little slower than the liquid. Is most common, is the most common method used, and in this method the refrigerant is recovered in vapor state, and this equipment condensate the refrigerant into liquid, and after that enter in the cylinder in liquid state. Yes, because we are going to use this diagram. This is the diagram that we are going to use in order to recover the refrigerant. Doesn't matter if the method is liquid or vapor. And the third method is the push-pull method. This is a method for equipments with more than 10 pounds of refrigerant. Okay, it's for big equipments. And this is a method of two steps. And also is too quick. It's faster. The inconvenience. That method is not recommended if the equipment have a heat pump. That method is not recommended if the equipment have reversing valve. If the equipment have a reversing valve, it's not recommended. And also if the equipment have accumulators. In other words, in marine application, the push-pull method is not recommended, because the majority of our equipment, they have accumulator, they have reversing valve, and they have heat pumps. This is not recommended in our business. Okay, we are going to use normally liquid or vapor. The most common is the vapor method. And right now we are going to check the procedure to do that method. Okay, the first step is verify that the cylinder, the valves are off. Check the tare of the cylinder, how much is the weight, and verify if the weight is okay, is 19 pounds. Okay, we have enough space to recover the refrigerant of this equipment. In this moment, this equipment lose a little amount of refrigerant, and we are going to recover the refrigerant that the equipment have. Okay, that's the procedure. In this moment, the recovery machine is off, and both valves are off. Remember that this equipment have two valves, one valve for the low pressure side and the gauge for low pressure side, other valve for high pressure side, and the middle in order to select recover or purge. We are going to purge the system at the end of the process in order to eliminate small amounts of refrigerant inside of the unit. Yeah, and we are going to purge the system at the end of each method. All right, and the switch on off, and the LED to indicate that the process is complete. It's simple. This is a great equipment. If you will be dedicated to work in air conditioning equipments, I recommend try to buy one of those units. There are different manufacturers. Try to check in internet the reviews of the equipment in order to buy the best equipment as possible. Ready? We are ready to start. The first step, we are going to do this connection. Look at this. This is the set of gauge. That's set. Remember that in the set of gauge we have the low pressure and high pressure gauge. Low pressure and high pressure gauge. We have the valve for high pressure. We have the valve for low pressure. Valve and valve. We have one hose, the red hose for high pressure, and we have the blue hose for low pressure, and we have the yellow hose to transfer, the middle one. I use green because with yellow is not good for the whiteboard. Okay, this is the set of gauge. I'm going to locate the set of gauge over there, and we are going to connect the set of gauge in this way. The red, the high pressure, into the high pressure side of the compressor. Normally the smaller pipe is for high pressure and the bigger pipe is for low pressure. In the majority of the equipment you have caps with the blue color or red color. This is the red, this is for high pressure, and we are going to insert the red one in the high pressure, the blue one in the low pressure side. Try to keep the valves completely closed. The blue in the low pressure side, the red in the high pressure side, and the middle one, the yellow one, will be connected with the suction side of the recovery equipment. We're going to connect this one here in the suction side, and we are going to connect the extra hose from the discharge side of the unit, the discharge side of the unit, into the liquid port of the cylinder. You have liquid and you have a vapor. In the liquid port or high pressure port. Okay, right now the set is connected in this way. High pressure with high pressure of the compressor, low pressure with low pressure of the compressor. The middle one in the suction side of the equipment, and the additional hose in between the discharge and the liquid port of the container. That's simple. This equipment is off, the set of gauge are off, and the cylinders are off. Right now we are going to open the valve of the cylinder. We are going to open the valve of the cylinder, and we are going to open the discharge valve of the equipment, and we are going to open this one right now. Open, and we are going to release a little pressure over there to bleed the air, and you tight again. And right now we are going to open the low pressure side. We are going to open the low pressure side, and we are going to verify we have 18 psi of pressure. And right now we are going to start the system to suction. The needle is going down, 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 down. It's down. Okay, now the equipment finished. And we are going to turn off turn off the valve. We are going to stop the equipment, and we are going to purge. We are going to purge the system. We are going to select purge, and we are going to open both valves, and we are going to start again. The system stopped by itself, is properly purged, and right now the system is ready. I am going to close the valves, close the valve on the cylinder, and the system is fully recovered. Okay, right now we can start with the reparation. We can remove the compressor, remove the evaporator, we can replace the unit, and we can put in back the lines, and before we recharge the system, we are going to do the vacuum. The vacuum procedure, in the vacuum procedure, we are going to use the vacuum pump.
And now, in the same equipment, in the self-contained unit, we are going to analyze the procedure to do the vacuum and how to do the vacuum in that equipment.
As soon as you recover the freon, the refrigerant, now you need to do the reparation. You need to replace the compressor, you need to replace the evaporator, in some cases you need to replace the reversing valve. In marine application, it's not recommended brazing, it's not recommended soldering. It's recommended cut the lines, and use the flare kit. Use the flare kit in order to repair the lines. Normally the lines are in copper. The majority of the equipments use copper lines. You cut the line, you do the flares, you install the adapter, and you fix the problem. As soon as you replace the part, you replace the equipment, and you are ready to put in back the refrigerant. Before you put in back the refrigerant, you need to do the vacuum on the system. You need to purge the system and vacuum the system. Vacuum the system is an important process because you need to eliminate moisture. Moisture is the enemy of the refrigerant, and you need to eliminate solid particles, contaminants. The enemy is moisture and solid particles and air. For that reason, as soon as you cut the lines and you separate the lines, the first step is cover the lines in order to avoid the intrusion of particles, the intrusion of humidity and nitrogen. Okay. In marine application, it's not recommended soldering. In some cases, if you wanted to soldering, I recommend soldering introducing dry nitrogen in the lines in order to avoid the formation of cupric oxide. Cupric oxide is no good because when the cupric oxide is mixed with the humidity, produce cupric acid. When the cupric oxide is mixed with the humidity, when the water, with the moisture, produce cupric acid or cuprous acid. That's no good. That's lethal. Okay. In that case, avoid soldering, avoid brazing. In marine application, it's recommended cut the lines, do the flares, and install the fittings. This is one of the most important parts. Okay. Now we are going to do the process for the vacuum. In order to do the vacuum, we need the proper vacuum machine. This is the vacuum pump. It's a two-stage pump. This pump is important, the quality of the oil. The oil should be clear, should be transparent, and should be according with the level recommended by the manufacturer. If it's possible, if you see that the oil is a little yellow, I recommend replace the oil for a fresh oil. The oil recommended for that specific pump. And easy, you open here, you replace the oil, you drain in the bottom, it's easy, replace the oil. Keep the oil, new one, keep the oil in good condition. This is the recommendation for those specific pumps. Okay, you need a line in order to connect the valve of the pump with the low pressure side of the equipment. You can use any part of the low pressure side. And yes, you have the line connected in the low pressure side. And I recommend also a vacuum gauge. The vacuum gauge is critical in order to determine if the process is complete. The majority of the technicians say, no, I I connect my vacuum pump for 40 minutes, for 1 hour. And with 1 hour, I am 100% sure that the vacuum is complete. Probably no. Why not? Depend on what? Depend of if you have leaks. For that reason, one of the most important part before you do the vacuum process is verify that you don't have leaks on the system. How can you verify that you don't have leaks? No, my system is hermetic. I am 100% sure. I am 100% sure that I don't have leaks because this system is hermetic. Are you sure? Because all the system have a little micro leaks. It's impossible a full hermetic system. All the system have small leaks, especially in marine application, because in marine application we use a lot of fittings, flare fittings, and those fittings have leaks. It's not 100% tight. Okay, how can I verify? I can verify introducing dye, the developer. How can I introduce the dye? There are different ways to introduce the dye. With this, you suction the dye and you introduce the dye in the system. You introduce the dye, and after that, with a flashlight, especially for UV, you can determine where is the leak. Yes, you have different type of dyes. You have different type of dyes depending of the refrigerant. This is for R134A, but there are other ones for R400, and they have the fitting, the adapter. They have the adapter to connect on the system, and right now you introduce the dye. And after that, with the flashlight, it's easy to identify where is the leak. This is a simple way, or you can pressurize the system with dry nitrogen. With dry nitrogen in a canister like this, and that system is a perfect system to identify if you have leaks. But if you have the dye, it's too simple. I recommend use the dye. It's a simple way to do that process. Okay, we are going to do the process of vacuum. We are going to connect our vacuum pump. This is the valve. We verify that the level of oil is appropriate. We connect on the equipment. And after that, we are going to be ready with the vacuum gauge. The vacuum gauge, I connect the fitting here, the adapter, in order to connect properly the vacuum gauge. And we are going to apply power on the pump until the reading on the vacuum gauge will be around 500 microns. No, Mr. Lopez, I don't need that. I am going to read with my gauge, the gauge of my set. With this gauge, I can read. No, my friend, because this gauge is set in PSI. PSI is a large measurement. This is microns. It's microns. It's 1 divided of 1 million. Is a teeny measurement. This is big measurement. That's impossible with this gauge read if the vacuum is appropriate. For that reason, I recommend the vacuum gauge. And you connect the vacuum gauge if you are applying the suction, because that pump produces negative pressure, suction pressure. If I apply the suction in the low pressure side, I am going to put the vacuum gauge in the high pressure side. Too far separated. Now, the system is properly connected. The vacuum pump is properly connected. Both terminals closed. The level of the oil appropriate. The cap of the oil properly closed. The hoses ready, and the vacuum gauge connected. In this moment, it's 3100 microns, and the idea is go until 500 microns. This is the microns recommended. We are going to start the process right now. In this moment is 3000. $2,900, $2,800, $2,600, 1,700 microns, 1600 microns. Now 1200 microns. And the process continues going down, down, down until 500 microns. We are in front of a chiller unit, and we are going to do the vacuum procedure. First of all, we are going to check the pump. In this moment, the level of the oil in the pump is too low. We are going to add oil into the pump. We are going to add the recommended oil for vacuum pumps. And we are going to check that the oil be at the level. Correct. That's the maximum. We are exactly at the limit recommended by the manufacturer. We are going to put them back. We are ready. We are going to connect the pump properly. We are going to insert the hose. That's the hose. And we are going to put the hose in the low pressure side of the system. I prefer in the low pressure side. And we are going to install the vacuum gauge. In this moment is 4200, 4250 microns. And we are going to start the process. The vacuum gauge. Remember that we can use a vacuum gauge digital. This is another good vacuum gauge, or this one. Both of them are excellent vacuum gauge. We are going to start the process right now. That white vapor is humidity. Humidity going out. I found a lot of water when I recovered the freon in this unit. You see, the oil is foaming. This is an indication of a lot of humidity in the system. But the system starts to stabilize slow until the majority of the humidity is removed. Remember, the function of the vacuum pump is remove moisture. Remove moisture. Yeah, normally that process takes 40 minutes, 45 minutes. It's a long process until the system be completely empty of moisture.
Now we are going to do the recovery process in the stand that we have on the lab. In that stand, in that board, we are going to do the process of recovery in this way.
Okay, now we are in front of the training unit, the air conditioned training unit that we have prepared for our students. This is the cooling tower. Remember that the cooling tower replaces the seawater, and the seawater enter and return into the coil of the condenser. In this particular example, we have two types of condenser. This is a water-cooled condenser, like the condenser used in our marine equipment, and this is the air-cooled condenser. This is similar to the condenser that you have in your home, in the residential units. Those type of condensers. The compressor is a hermetic compressor, and we have the high pressure side and the low pressure side. And in this particular example, we have a low level of refrigerant. In the high pressure side only have 30 psi, and exactly the same 30 psi in the low pressure side. In both sides we have a low pressure. For that reason, today we are going to recover that refrigerant. We are going to do the vacuum, and after that we are going to charge the system again. And in this training equipment, we have two evaporators, one static evaporator and other air-cooled evaporator. Two evaporators. We have the different type of expansion valves.
the different type of expansion valves commonly used. We have the typical capillary pipes, expansion valve, and we have the thermal expansion valve. This is the different type of expansion valves, capillary pipes and thermal expansion valves. Alright, and in this particular example, the forward and reverse cycle on the Y valve is manual. You select forward and reverse depending how you want it in the system, if you wanted a cooling system or heating system. The high pressure coming from the high pressure of the compressor enter in the middle of the Y valve, and depending on the position of the metal, the high pressure fluid goes over there into the evaporators, and the system is working in the heating mode. If the metal is located in this portion, the high pressure refrigerant goes over there and goes into the condensers and work in the cooling mode. Yes, the secret is where is located internally the metal. That movement is possible because this solenoid receives a signal 24-28 volts AC coming from the computer, the board of the equipment. Okay, right now we are going to recover that small amount of refrigerant, and after that we are going to do the vacuum. We are going to recover with our machine. Remember that the machine have one input, the inlet, low pressure, with the low pressure gauge. This is the discharge, and with the high pressure gauge, and this is the valve to purge or recover. In this particular case we are going to recover. At the end we are going to purge the system again, and after that we are going to charge the refrigerant again in the system. This is the perfect training equipment, and yes, we have the cylinder and the scale in order to tell the amount of refrigerant that we are going to recover. Okay, I am going to put my camera ready here in order to verify if it's okay. I think that right now it's okay, and we are ready to start with the system. The first step is open the valve on the cylinder, open both valves on the recovery machine, and after that we are going to bleed a little air in the system. Right now it's bleeded properly, and we are ready to open the suction valve, and we are going to start the system. Okay, we are ready. We are going to select the valve in recovery position, open this valve, and right now we are going to recover. Pretty close to zero and pretty close to zero. In any moment the system stops suddenly. The system stopped by itself. We are going to turn off the power. We are going to wait a couple of minutes, and after that we are going to start the system again, and we are going to switch the system to purge. Now we are going to select purge in the bottom, and we are going to
purge the system in order to eliminate a small amount of refrigerant in both sides of the system. Okay, the system is stopped by itself, and right now the system is ready to recharge the system again. Now our system is empty. We do the vacuum. The system is ready to put in back the refrigerant. To put in back the refrigerant, we are going to connect our set of gauge. It's exactly the same. The high pressure line in the high pressure side, the low pressure line in the low pressure side of the compressor, and the middle one connected directly to the recovery tank. Normally, the refrigerant is added in the vapor side through the low side of the compressor. For that reason, we are going to open the valve of the cylinder. We are going to start the air conditioning equipment, and after that we are going to turn on the valve of the low pressure side to introduce the refrigerant into the unit. Because in this moment the unit is empty, we are going to add a little amount of refrigerant into the system. We are going to open that one and open the cylinder to add refrigerant. And now we are going to close again, and we are going to start the system. Remember, for R134A, the low pressure side should be around 55-60 psi, and the high pressure side in between 225 and 280 psi. Okay, we are going to check right now. We are going to add it, refrigerant. In this moment is in the blue scale, is around 60-75. It's okay. And now we are going to open. We are going to close again. The system is 75, it's closed, it's good. We are going to open again. That's perfect. We are going to close again. The idea is open and close until the pressure is stable. 70-80 psi is okay. It's 75. Remember, it's the blue scale. Increase a little. And go down. And right now, I am going to close the cylinder. Okay, right now, the low pressure side is 60-65, and the high pressure side is 225-230 psi. The system is ready, the air is cold, and the system is working properly.